Hey everybody, this is an optional supplemental video where I just thought I would walk through a whole bunch more examples of how to find sine, cosine, and tangent of various angles for those that wanted some more examples or explanations. So feel free to use this however you need. It'll be a little bit longer than the main lecture video, but hopefully it is a useful resource for you. So let's dive back in. I'm going to use the approach again of drawing these every time. You could look them up on your unit circle, but I think long term it's better to understand where those values come from with the triangles and the connections it'll make to Thursday. So 210 degrees, I know is 30 degrees past 180, so I'm over here. I know my hypotenuse is 1. And if I think about my unit circle, okay, this is like 30 degrees here, 60 degrees here. So the 60 is the bigger side, so this is root 3 over 2, and it's to the negative direction. And this one's going to be the negative 1/2 in the downward direction. So therefore, my cosine of 210 degrees is negative root 3 over 2, and my sine of 210 degrees is negative 1/2. All right, let's go ahead and again, that comes from our 30, 60, 90 pattern. 2 pi over 3, again, probably involving a 30, 60, 90 pattern. 2 pi over 3 is 120 degrees, so I know that's just past 90. So that triangle has a reference angle of 60 degrees, or pi over 3 short of pi. Hypotenuse of 1, and therefore the shorter side is here, negative 1/2. But now I'm going up on the y, so that's root 3 over 2 on the y. So that point is negative 1/2 on the x-coordinate, root 3 over 2 on the y-coordinate. So again, the cosine of 2 pi over 3, writing out the whole thing. So you take the cosine of an angle, and it outputs a ratio, is negative 1/2, and the sine of 2 pi over 3 is root 3 over 2. All right, and on this page, our last example here, ooh, a negative angle. Love that. So negative pi over 4 is like negative 45 degrees. It's going to be rotating downward. So again, negative pi over 4, its reference angle is 45 degrees, or pi over 4. The hypotenuse is 1 because it's the radius of that unit circle going around. And we learned that these were equal values, so root 2 over 2, root 2 over 2. But of course, it's going down on the y, that's a negative value, positive on the x. So the cosine of negative pi over 4 is positive root 2 over 2, the x-coordinate. The sine of negative pi over 4 is the y-coordinate, negative root 2 over 2. And again, you could easily look these up on your unit circle, but as you get more used to it, we want you to get good at drawing them out again and re-envisioning them in your head. So let's look at a couple more examples on the next page. Okay, so these again are examples we didn't get to during the main lecture video. We're looking for the tangent of theta equaling 300 degrees. We know tangent, of course, is the sine value, or the y-coordinate, divided by the x-coordinate, so the sine divided by the cosine. So therefore, we've got to find the sine and the cosine, much like we just did in our previous problems, for 300 degrees. So 300 degrees is going to go all the way around and then be 60 degrees short of where I'm looking. So my reference angle here is 60, giving me this 30, 60, 90. I know the hypotenuse is 1. The longer side is across from the 60, so the root 3 over 2, it's going down, so it's a negative, and then a positive 1/2 for the x. So in this case, again, this would be my cosine value. This would be my sine value. So therefore, the tangent of 300 degrees is sine divided by cosine. So sine is negative root 3 over 2 divided by 1/2. As we go to solve this, again, I'm using the idea that if I'm dividing two fractions, I can multiply by the reciprocal of the second one. The 2 over 2 will simplify, and I get negative root 3 over 1, but I just need to decide it as root 3, negative root 3. So tangent of 300 degrees is negative root 3. Again, find where it's located on the unit circle, use the sine and cosine values to calculate your tangent value, since it's that TOA, that opposite over adjacent value, the sine being the opposite, the cosine being the adjacent. So that really helps. All right, again, I'm going to do a lot more examples here just for you to see. You can skip ahead to look at him, or if you're ready to attack the homework, feel free to do that as well. So again, we'll focus on tangent here. One of the nice things about tangent is that it makes you go through everything. You've got to find the sine and the cosine in order to find tangent. So let's go ahead and get started on our first example. We're looking at 240 degrees. That's 180 plus 60. So my reference angle is going to be 60 here. And so right away, I know I'm bigger going down. So that's negative root 3 over 2 and negative 1/2 for the x. So the tangent of 240 degrees is going to be sine divided by cosine, the sine being the negative root 3 over 2, divided by the cosine of negative 1/2. That winds up being negative root 3 over 2 times negative 2 over 1. The 2's divide out. The negative times negative would be positive, so I wind up with a positive root 3. So the tangent of 240 degrees is square root of 3. All right, 690, a little bit more difficult, but we can do it. So 690, it's really 360 plus 330. So I go around all the way once, that's 360, plus another 330. So I'm actually finishing again 30 degrees short of there. So I had a reference angle of 30 degrees here. And so it's again this classic 30, 60, 90, the longer side root 3 over 2, the shorter side 1/2, it's going down, so it's negative. So the tangent of 690 is equal to sine divided by cosine, so negative 1/2 divided by root 3 over 2, negative 1/2 times 2 over root 3. The 2's divide out again, that's nice, but we have a small problem that I get negative 1 over root 3. So to rectify that, I have to multiply by a sneaky form of 1 to get the radical out of the denominator. So multiply by root 3 over root 3, and I get negative root 3 on the top, and root 3 times root 3 is just regular 3. So I get tangent of 690 degrees equals negative root 3 over regular 3. So again, 690 a little bit tougher because we had to think about how far around it went. Same thing with the next example of negative 585, but we'll keep going. All right, negative 585. Again, you're seeing here how I do these. I do not memorize the unit circle. You could have it next to you to kind of help you speed it up a little bit, but I really like being able to just kind of remember the structure here. So that is negative 360 plus negative 225. So I'm going negative, so that's down. So I go around once, and then negative 225, so negative 180 plus another negative 45. So I wind up here, visualizing on the unit circle. That reference angle is going to be 45 degrees. So that means these are equal. It's my root 2 over 2 number that we've seen through the Pythagorean theorem. So positive on the y, negative on the x coordinate. So the tangent of negative 585 degrees is equal to sine divided by cosine. So root 2 over 2 positive divided by negative root 2 over 2. Now, you might say, wait a second. Don't we have to, flip the fraction here? So root 2 over 2 times 2 over negative root 2. You could, but essentially you're dividing by the same exact number, and anything divided by itself is going to be 1. Like a million divided by a million is still 1. So therefore, root 2 divided by root 2, still 1. So 2's divide out, the root 2's divide out. In this case, the negative 1 is left over. Sometimes you'll get positive 1, but in this case, you got negative 1 for the tangent here. Opposite over adjacent. They're the same side, so the ratio is 1 to 1, in this case negative because of the negative value. All right, we'll keep rocking and rolling. We did that one in the regular lecture, so we'll take a look at 7 pi over 3 here. So again, just thinking about where this is on the unit circle. This is 6 pi over 3, also known as 2 pi, plus pi over 3. So I go around the circle once, and then another pi over 3. So really, it's the same values as if it was pi over 3. Pi over 3, of course, is similar to 60 degrees. So this is going to be my taller one, root 3 over 2, and the positive half for the shorter side on my 30, 60, 90 pattern. So the tangent of 7 pi over 3 equals sine root 3 over 2 divided by cosine 1/2. Some of you might even see how this is simplifying quicker. Root 3 over 2 times 2 over 1. Tangent of 7 pi over 3 equals positive root 3. Okay. Negative 9 pi over 4. So in this case, that is negative 8 pi over 4, or 2 pi, minus pi over 4. So I go negative rotation plus another pi over 4, or minus another pi over 4, so I'm winding up in this direction. It again is my 45, or pi over 4, pi over 4, 4590, so I get equal parts. We now know that's root 2 over 2, positive in this direction, root 2 over 2, negative in this direction. So the tangent of negative 9 pi over 4 is equal to negative root 2 over 2 divided by positive root 2 over 2, and that's going to wind up being negative 1. So actually, all of these kind of 45 angles that split the quadrants, they're all going to be positive 1 or negative 1, depending on where they land. So that's kind of a neat thing. All right. Again, you can pause this at any time. I'm just doing a lot more extra examples. These are the last two that we're going to do, and then hopefully you feel pretty confident doing your homework, as well as we'll set up some type of automatically graded thing for your test next week, where we'll give you random angles and ask you for sine, cosine, and tangent of these, any kind of version you've seen here. So let's look at 495. I'm going to look at that as 360 plus 135 when I draw my picture here to see where it ends up. So I rotate once around and then another 135 degrees. So again, it's splitting that second quadrant. It's at 45-degree reference angle. And so I get 1 for my radius or my hypotenuse, positive root 2 over 2 on the y, negative root 2 over 2 on the x. You can see that on your unit circle too. So the sine of 495 degrees is equal to positive root 2 over 2. The cosine of 495 degrees is equal to negative root 2 over 2. And finally, the tangent. Got to do a little bit of work here, but hopefully you see where it's going. It is the sine, root 2 over 2, divided by the cosine, negative root 2 over 2. So the tangent of 495 is equal to negative 1. Okay. And now for number 8, we're going to have similar values because notice it's a pi over 4 value, so it's on that splitting the quadrant piece. It's on that kind of 45-degree pattern. So 7 pi over 4 is just short of 2 pi, so it's over here. So I'm pi over 4 short, so again, that's that 45, 45, 90 pattern. So I get positive root 2 over 2 on the x, negative root 2 over 2 on the y. So in this case, my sine of 7 pi over 4 is equal to negative root 2 over 2. My cosine of 7 pi over 4 is equal to positive root 2 over 2. And the tangent, of course, is dividing the sine by the cosine. So actually, this is a lot like negative 9 pi over 4 that we saw prior to this. So negative root 2 over 2 divided by positive root 2 over 2 leaves me with negative 1. Okay, keep practicing. I'll be available for office hours as needed on Tuesdays and Thursdays at 10 a.m. and at noon. For a full hour, just feel free to drop in at any time during that point. Take care.